We'll start today with the Spark architecture. Spark architecture. Now, what are the main components within this architecture we'll discuss today? Module, we have seen how many different modules are there in Spark. Now, in Spark core, so we are talking about the core architecture first. Architecture. Now here, as I said, we focus on two things: DAG and RDD. Every time your internal execution will follow a DAG model, and whatever data you will be processing, it will be RDD, whether it's a standalone or S3 or HDFS, wherever you are storing the data. Now, when I say DAG, let me give one example of DAG, practical example. Okay, so we often carry forward our result here, right? So one variable output I will carry forward to second variable. So we have seen this example in Scala. We'll try to see the same thing using Spark API. So question is this: we have 100 numbers, or we have 100 natural numbers from 1 to 100 natural numbers. Then we said find out only odd numbers. Find out odd numbers. Okay. Then multiply all the odd numbers. So if I ask 1 to 100, there is a natural number, and we want to find out odd number in between this. So there will be 50% odd numbers, 50% even number. So find out odd number, multiply all odd numbers with 2, okay, as in 1 into 2, 3 into 2, 5 into 2, and aggregate them, and aggregate as in sum them, sum all the value. This is the requirement. Now if I want to do this in a Spark, I have to follow the DAG model. So I'm not writing the code first. What will be my approach? So if I know approach, I can write code also. Okay, my first approach is create the data. Always, whenever you have any question, do not directly think in aspect of how we can write one line, second line, third line. Start first your soft plan. This approach is known as a soft plan for any program. So things will be easier for you. First approach is to create a number. Create a number. Now here I'm saying create a number, or maybe you have already number available in your hard disk, in your local machine somewhere. Okay, it can be Windows, Unix, or any operating system. You can read directly file from there. So create a number or read a file which has this dataset already stored in the file. Create a number or read a file, whichever is fine with us. Second, after creating a number or after reading a file, we need to find out this. Okay, so for reading a file, we'll have to call a function. Let me change the color. This function would be read function. This function is a read function. Now, what Spark internally does, again, 2 points I will discuss about Spark. When we compare with MapReduce, we said Spark is designed for interactive processing. Now, what do we mean by interactive processing and in-memory processing? Okay, so if I'm reading this data, suppose I said A is equal to read, and I'll pass that file name here. This is not a code, guys. This is just a pseudocode. Okay, code will see. read and file name. So if I'm reading and passing the file name, so whatever information is available in this file, it will store in this variable, which is A. Now next time if I'm doing, this is my step number 1. If I'm second time doing another activity, I'll say B is equal to, what I want to do, I want to find out the odd numbers. Now, how do we find out the odd numbers? If you check Spark API or Spark inbuilt functions, we will be using these three things a lot in Spark space. In Spark, there are 80 inbuilt functions available, which are very powerful. Okay, there are 80 functions available, but I can create my own function also using Scala. That's why we need a programming language, either Scala or Python. Both uses same syntax, so hardly it's a problem if you know any one of them. I'll be using these three functions for transformation and aggregation. Map mainly does transformation, then filter. This will give you only result which you are looking for. So condition, based on the condition, in this bracket we pass the conditions, right? We pass lambda conditions. So if I give here a condition, what will happen? It will only give us odd value out of 100 numbers. Then I will aggregate them using a function called reduce. So we'll be using these three things here. First, I said read the file. It is caching here. Now, is it caching always, or it's up to me? It's up to me. If I don't want to cache it, I can remove this from here. But caching is always a fast business, so we'll focus on the caching, because disk operation we already have seen in MapReduce how disk operation works. A dot. This is what I mean interactive queries. Whatever is there in A, I'm using A dot. So A input will be referred here, and then dot is a carry forward operator. This will carry forward and say, now what do you want to do? Since my second requirement is this, my first requirement was this, so I'm reading the file, or maybe I'm creating the file. Then second requirement is this. Here I will say A dot filter this, and I will write some condition here. Based on some condition, it will filter out this data set. Now, whatever you are doing in this second step in A dot filter, and you're writing some lambda conditions, this output will be stored in this variable, which is B. Now, I can use A and B together also in my third step if there is some requirement which says I need input from this both. But the best part is here, when I am reading this input file, I have cached my data. I have cached my data. If I have cached my data, then I'm not again processing it. I'm just passing this A. So automatically data from RAM will come here, right? When I say caching, we'll see this using our dashboard also. I'll open one dashboard and I'll show you how you can watch things by your own. You can actually see DAG also graphically. Okay, so Spark provides you one port number. Let me write that port number, 4040. So using this port number, we can see whatever activity is going on internally for the Spark core. So A dot filter. Now whatever output is there, it is stored in B. And then step number third. Here I'll say C is equal to, okay, B dot now. So if you want to do A dot, you can do that A dot, but already the output is filtered. So I'm storing that output in B. And now next third operation is multiply all odd number with 2. If I want to multiply, I will use map. This is for transformation. Okay, map, and here we'll pass again some condition. Based on it will maybe multiply with 2, or it will square it, or it will divide it, whatever condition you want to pass. Every time whatever you write in the right side, there their output is being cast in this variable, which is your left side variable. And we are referring this variable because this is the variable which is caching the data, And then fourth operation would be my last operation where I want to aggregate this result. I want to sum the final result. So here I'll say D is equal to C dot. D is equal to C dot. Now here I have cast information C dot. I want to use reduce now, or I can say sum also. Let me take reduce, because reduce can do plus, minus, all binary operations it can perform. And again, I will write sum condition here. Now, this thing is nothing but my DAG. I first said, let me go back to this picture. This is my DAG. First I said, read the file. Then I said, map the file. Sorry, filter the file. Then I said, map the file. Then reduce the file. Directed acyclic graph. Are you revising any step here? Are you going back to your previous cycle? So it's not completing any cycle, hence it's a DAG operations. Now I will write my RDD, resilient distributed data sets, within this. So when I'm writing this operations, I will write RDD inside this. While reading the file itself, I will define the RDD. RDD always operates with two different functions. One is actions, and this is the most important thing to check about RDD, because this would be the question. Here I'm talking about, I said 80 powerful APIs are there in Spark, or 80 functions are there. Now question often come if you're doing certification also, like CCA 175, or if you're giving interviews, most of the time you'll face which API is a transformation API and which API is an action API. RDD always works in this two form, transformation and action. Now, how do we know that? Before moving to transformation and action, let's talk about the Spark architecture. So one example, we have seen how things will go inside. After checking the Spark architecture, we will go back to our program and we'll start writing this. I'll use IntelliJ extensively. I'll show you first in Cell how can you write this, same as Scala, and then we can go to IntelliJ. So Cell is always for syntax checker. If anywhere you're starting, that's my personal use case. If you want to do, it's an easy thing. So this I will be writing in Spark context. I will write this DAG. I will write this DAG in a Spark context. So there is one SC utility. S stand for Spark, C stand for context. This is often known as a driver program. This is often known as a driver program. Now I'll relate one thing here. When we were writing Scala program, so we said without main method, nothing will work, right? And always main method is a part of object. Always we are writing that main method with an object, right? Let's say here I said object. So I'm writing one program in IntelliJ for Scala. So I said object test, and then we write here a main method, def main, then we pass here arguments, array, string, then this is unit, and within this parenthesis, we write our logic, our business code. So without this diff main method, If I'm not writing this diff main method, if you right click and see, your run option will never come because you won't be able to execute it. Compiler will never wake up if you do not call your main method. Similarly, in a Spark, we have driver program. So if I'm not writing driver program, my method will never be called. So you can consider this as a main executions method. I'll be first writing DAG in my program, then a Spark context I'll open. Without a Spark context, I cannot use any API. Without a Spark context, I cannot go to the next line. All the APIs, all the scheduler is part of a Spark context. This is coming from where? Spark core, right? And if you remember our graphical visual, we have created one Spark core first in this layer, base layer, and then top of that we had all Spark SQL, streaming, machine learning, and graphics. So main part is a Spark core. This is in a Spark core. A Spark context will say, now I want to submit the program to Spark cluster. Now, Spark cluster also follows the same methodology as Hadoop, master and slave architecture. Spark also has the same thing, one master and multiple slave. Now, how do you configure this Spark thing in multi-node cluster using master and slave architecture? So master you define in name node, obviously, because name node is a master, and all the worker node or executor node, as in slave node, we will be defining their slave thing. So master with name node and slave with the data node. That's what we can consider for now. This DAG will go to whom? Cluster manager, obviously, to look for resources. Because if I want to submit something, suppose this is what written in a Spark context, and I want to read the data. This is just a logic, guys. This is my logic. Where is the data stored? If I want to process it, if you remember the MapReduce algorithm again, let's relate that because this is top of MapReduce only. You had data node and then you had node manager. So data node used to store the data, node manager used to process it. Here I'm storing this data in my, so suppose you are trying to process number 1 to 100. Let's say that 1 to 100 number, I'm just taking one rough example, that size is 100 MB. Suppose each number 1 MB, okay, which is very high, but okay. Now a size we can define. 100 MB means if this is stored in HDFS, one block, if this is stored in HDFS, one block, right? So this will go to cluster manager, and that cluster manager, and here I'll write cluster manager. This cluster manager is nothing but our yarn or mesos computation layer, which computes your CPU RAM requirement from program. Now, being a driver program, my job is to only submit this DAG to cluster manager. Now it's a responsibility of cluster manager to check whether resource is available in the cluster or not. And if you remember how many daemons we have in yarn, there was 2 daemon, resource manager and node manager. Resource manager job is to provide the resources. Node manager job is to execute the task one by one. Now here I don't have node manager services. Cluster manager is like if I just use one metaphor, you are visiting to a restaurant, you ordered some food. Manager is coming and asking, sir, what do you want? How can I serve you? He's not bothered that whether you are you want what kind of food. He just asks you, give me your order. You say, okay, wait 10 minutes, I'll call you. So again, he's coming back and asking, how can I serve you? Then you say this, he'll place that order to their kitchen rooms and start serving you. Similarly, exactly same concept we're having here. We have executors we have executors here. Executors are my slave node. These are my slave node. Executors are my slave node. So I can use both. I can interchangeably, I can call sometime executor or slave nodes. Remember, whenever I say executor, it's a part of slave node always. So master job is to just interact with the slave. Now this cluster manager will find out 100 MB data is present in which machine, in this machine or in this machine. Let's say 100 MB data is present in this machine. And obviously if it is HDFS, it is following the concept of replication factor. So it has replicated this block 3 times in this 2 machine or in another machine, one more machine. I'm just creating this standard architecture. And here are my data sets available. These are my data already available in form of 100 MB. Let's say 100 MB is there also, and some other file is also present. Some text data is also present. These are my data sets. Now what cluster manager will look? Cluster manager will check what is the number of CPU and RAM available in your total cluster. And then if it finds out this logic is created to process 100 MB and that data is nearly available in this machine. Let's say this is the data set D, I'll call. This is the data which is having 100 MB of file. Now immediately cluster manager will submit this program to here, that jar program to this machine. If I'm processing 2 block, so it will submit here also. We'll take example of 2 blocks, okay, so that we can understand the caching also. I have submitted this this DAG in this 2 executor node, which are my slave node, and then they start processing it. Now, use of caching is centralized cache, shared variable, broadcasting variable, many things we're going to see here. Now, suppose this task is processed. This is done, and this is running currently. This is running currently. Now this is having dependency on this task, which means whatever I did in this task, some 40% operation is common in this one and this one. So what will happen? This machine can read the cache from here directly. This machine can read the cache from here and process it. So obviously, if this is taking 10 minutes of total time for execution, this was also taking 20 minutes. If I'm reading data from here, my 40% operation, I'm not revising again in this machine. I'm directly reading it from here, from one executor node to another executor node. They will take some time, and RD demons. If this task is failing, okay, if this task is failing while processing first task, so they try often time, and I said the number 16 time minimum they try. And that is why we are calling it's a resilient. Resilient means a person who never give up. That's what we use this term. Okay, resiliency. So similarly, Spark is resilient. Spark is continuously checking. Once the final output is executed, then they will display back to your driver program. Whatever is output, it will revert you in the console. This is what is happening typically within a Spark. You have data sets, you have executor node. Now, in the case of executor node failure, what is happening? If this executor node gets down, so task is down, they are resilient. If this is down entirely, then what will happen? If this is down, then obviously it will communicate to cluster manager, or it will communicate to context and say, this is no more available. Then I will be doing commissioning and decommissioning, which is a part of Hadoop. So Spark is sitting always top of your HDFS and MapReduce. These 2 applications, top of this, it will be standing. Now we'll download our Spark file, a Spark software in local machine first, and then we will check, just like Scala, how can we run these programs and prove things whatever we are conceptually trying. Okay. Now here we can go and download this file. You can open a new window and search for Spark download. Spark download. You can give a version also. No need to pass a version. You'll get all the latest file here. Click on this. Don't go with the latest version. You can take this. But 2.4.6 looks like just 10 days ago. What is the today's date? It's 16 June. This is 5th June 2020. So always I said always go with the lower version, but since that lower is not available, can we type Spark download and index? So you get this index link. Click on this index. In this index, you'll get this version 2.2.0. So we can look for the highest file size, which is Spark. One second, Spark bin Hadoop 2. Yeah, this is the file. The Spark bin Hadoop 2.6.tzz tar file. I can download this, or I can download this also. This is with 2.7. This is with 2.6, but it doesn't make any difference. 2.6, 2.7 is kind of same. If you want to work with the Python only, you can download this file, PySpark 2.2.0.tar.config. By the way, if I download this file, I'll get all the things directly. This is just for your syntactical check, okay, like a spell checker. So this is already with me. I'll open my cell and go to that folder where Spark is already present. We'll find out downloads. We'll go to setup. We'll go to Spark. I have 2.1.0 and Hadoop version is 2.7. lslrt. You can see this bin, Python, R. Now it is up to you which one you want to use it. By default, this is for Scala. Okay. By default, if I go to this bin, this is for Scala. Otherwise, if I want to go to Python, let me go to Python, because Scala anyway we are going to see. Other option also I will show you. There we will find one PySpark. Let me see where it is. Yeah, the last option is PySpark. So if I type PySpark, it will give me one option for Python with Spark. If I want to go with R, because we said Spark supports 4 programming languages, right? I'll directly go to my bin and check for a Spark cell. Spark cell is this. So if I type Spark cell, it will open one cell, and there I can start executing it. If I have created a jar file, if I've created one program file which will run in Hadoop server, so I can submit this Spark submit program. Now let me run a Spark cell to open the cell and check how can we prove the points here. If you're using Unix or Linux machine, you use always /spark-cell. Otherwise, if you're a Windows user, then no need to use this thing. Automatically, you can type only Spark cell. Automatically, it will take it. Enter. Here I will get by default SC, because every time everything starts in a Spark with this thing, Spark context. So I'll be writing a Spark context, and then I can access RDD, because without a Spark context, I cannot access RDD. I will show you how. RDDs are kind of lazy. So you have known the concept. We already have seen what is the use of lazy in Scala. This is pretty much lazy functions. Let's wait. Once this is open, we'll start doing our operations. So my cell is open with a 2.1.0 version, and now here I will write SC just to check Spark context is working or not. And I'll recommend you also. Yes, Atish. So I'll tell you that you know how you can run this in IntelliJ. This is just a cell. Currently, as we started with the Scala cell, so this is the same Spark cell. Now, if you wonder why I'm getting a Scala here when I type Spark, because Spark is built in Scala programming language only. So you won't get a Spark written cell. You'll get a cell of this only. Okay. SC is there. SC, if you read, it is giving me a package org.apache.spark.spark context. So this is the package name. Using this package, I can access my Spark context. Now, here I can run simple Scala program also. Okay, I can do things like this. If I want to read a file, I can pass a Scala package also. But I want to work with a Spark. So, well, now we know what is a well and what is a where. Well stand for immutable and where for mutable. If I want to open this, this is a link. If I copy this link, let me copy this. You can use your local host also, and you can use your this IP address also. This is my system IP address. What this line says: Spark context web UI available at this link. Okay, so if we go here and we paste it, you know what will open? When a Spark cell will open, and this is only active till my this cell is open. As soon as I quit from here using colon Q, everything will go away because this is in session variable. Now let me read this. Username is this. Total uptime is this. Scheduling mode is FIFO. FIFO is stand for first in, first out. It's a kind of queue business. Stages. I have not done any job, so it's blank. When I start submitting job, we'll see the stages also. Storage, environment will get. Environment and executor, this two thing is important. Environment, you can see first line Java home. So what is the version of Java here in Spark home? So this is my version 1.8.0 and 171. Scala version is this 2.11.8. Then Spark cell, it is available in this location, directory location, and mode is FIFO. Any other information? Currently, it is running in client mode. So mode I did not discuss yesterday. Let me take this point today. There are two deploy mode. One is a client and second is a cluster. There are two deployment mode. One deployment mode is a client mode and another deployment mode is a cluster mode. Client means you are working with a standalone. In this machine, currently I do not have any Hadoop services running. This is my local machine and this is not Cloudera, right? So can I call this is working with a client business? When I write this input file to HDFS, that time I can say that this is using the cluster deployment mode. So remember, there are two different deployment mode. One is a client and another one is a cluster. Client for standalone when you're not using Hadoop. If you're using Hadoop, it's a cluster mode, right? Cluster means multiple machine. Client means one machine or one edge node. Then what encoding type they are using. These are all system information. So if you want to read it, it's your choice. You can go and see the IP address, the version, and so many other information. What's your operating system? What's the version of your operating system? What library they are following? This is not important. User-wise, this is only important. Main tab for us is this executors, because this executors will tell us how much memory I can use for caching. Now my system is having 8 GB RAM. okay, with the SSD hard disk. So out of 8 GB RAM, you are getting 384.1 MB, right? 384.1 MB. Let's calculate. Let's uh, see in a math how much is this out of this. Now 8 GB RAM, if you ask me, can I say this is exactly 8 into 1024 MB, and 8 into 1024 MB. Let me use my calculator to calculate this. 8 into 1024 MB. This is 8192 MB. This is 8192 MB. Now, how much is this? What is the 1% of it? Now, if I want to check this, how much is this? What I can do, I can divide this 8192 by 384 by 384.1. I'm getting 21.32, and I'll just do opposite to get a normalized number. 384.1 divided by 8192. So this is 0.046. If I'm doing this, 8192, which is my total RAM available in this machine, and I'm getting 384.1. This will be your denominator, and numerator is 384.1 MB. When you divide this, you get 0.047. You get 0.047. This is total 4.7% RAM of my system. You guys can check, okay, you can check this. Is it the same number or is it a different number in your machine? 4.7% RAM out of total 8 GB RAM. This is what by default given by Spark for my machine because of 8 GB. If you have 4 GB, maybe this number may be different because 4 GB, 4.7% of 4 GB will be little less number. So this is the RAM, and I will use this thing for caching. This is what is for caching. You can see it's storage memory. So this is by default number. I can increase this value. I'll tell you how can you customize it. But currently I can only cache till this limit. Now what will happen if this is full? What will happen if this is full? So Spark uses also list recently used policy. Spark uses one policy, and that policy is a list recently used policy. Recently, same as HBase, we'll see in HBase also. Whichever operation works with in-memory thing, it works with this. Same as Impala, list recently used policy. What will happen in this? Suppose in cache, I can maximum deal with 1 query to 100 query, which means I can maximum store 100 cache at a time. I'm just taking a number. So a Spark program says you can maximum handle 100 cache at a time. What will happen if I type 101 cache? Because this is out of bucket. It's like you have a bucket and you filled something. Let's say you fill a water in this. If the maximum limit for this bucket is 100 milliliter of liquid can contain in this bucket. If you try to increase 0.1 also, that is going outside, that water is started leaking. The same thing will happen here, but it will not start leaking. What it does, it uses the smart approach. It says if you are using 101 query, 1 to 100 is the capacity, it is already stored. I gave one more query out of actual bucket. So my previous query will start deleting from the last. So first we'll delete now. Now it is having 22101. I have 22101 because 101 is going ahead, right? So they are following the FIFO method. What scheduler you have seen? They follow first in, first out. So in first in, first out, they'll start deleting from here. If I write, let's say, another query, which is somewhere this number 102, then it will delete the second also. And now I'm having from 3 to 102. So always it will maintain this 100. Currently this 100 I'm taking as a number, but whatever number you say, this is the maximum caching capacity. If you start giving more than that, they uses this policy to delete from the first cache which you have stored in your Spark. So two things, this is 2 point to take away from here. First, how much total RAM is available and how many things can cache in your system. Is it just in MB? It's having good configuration, good number of RAM is available where I can cache it. So this is about your RAM thing. Second, I'll go and discuss about core, because always we will focus on this thing, RAM and CPU. I don't care about the hard disk because hard disk is not increasing my performance. I'm not concerned about the storage. Storage we have huge limit. We have zettabytes of storage, but how we can optimize and or we can use smartly this RAM and CPU, that's more important here. Being a Spark programmer, there is not fixed formula defined that you should be using this number to create a RAM. If this is the number of machine, this is the RAM, this is the CPU. Unfortunately, that is not available, because if formula is available, then why they need a Spark engineer? Manager can compute things by themselves. So we need computing tuning between this two. This is the most critical job in a Spark. Frankly speaking, writing code or using a Scala, using a Python is just, you'll understand in couple of days when I start it. But computing and tuning, this is still we are learning, because learning never end here. Actually, learning starts from here. How we can tune this RAM and CPU based on the application requirement and based on the data size, obviously. So number of core is available for me is 4 currently. Number of core 4 available means I can process 8 a time, 4 tasks. 8 a time currently, this is giving me option for 4 tasks. I can process it. Okay. And that's it for now. So let's go and see this cell again. I want to create a RDD. Okay. So I know that if I say 1 to 100, if I say 1 to 100, this gives me 1 to 100 number. So I can create number like this, but this is immediately executing. In Spark, I have said two things. One is a transformation, and second is your action. First one is a transformation, and second would be your action. Now we need to see the API, which one is a transformation and which one is an action. One is small description about transformation and action. So transformation means, as the name suggests, you will not get output. You'll not get output. It will transform and return you another RDD. And by the way, these RDDs are immutable. Once you define, you cannot change it. These RDDs are immutable, similar as well. And that is why all this transformation works with the lazy concept. Okay, transformation works with the concept of lazy, which means immediately it will never execute. It will wait for your action to ask when you want to compute. And we have seen this lazy architecture. What is the use case of lazy? How can we take a best benefit of this lazy? So all the heavy lifting of your Spark can be done by this resilient distributed data sets. Okay, I'll start from here. So I'll say R is equal to, R is my reference variable. Now SC SC, because this is what you have to call always. Spark context. This SC is nothing but my Spark context. All the API I can use after writing SC only, because all the API is a part of SC. Now, obviously, I cannot remember everything, neither you can remember. So what we do, we use tab. When I use tab operation, it says me this many functions I can apply after SC. And always in Scala IntelliJ also, you see how it can recommend us. Here, it is also recommending us which one you want to use. You want to read a file using this function. So I'll actually start reading from beginning. I'll say, okay, so many things are there, but I want to read the file. Since I know, I'll tell you, this is the text file API, which will read the file. And it says if you want to create RDD, do we have any method? So there is a method to create RDD, which is a make RDD, and second one is a parallelize. These two methods we will use to create RDD. So we'll write up here. This is a method number one. Where is my make RDD? Method number one. Method number two. To create RDD, I'll call this make RDD and parallelize. Let's do that. Calling this to make RDD and parallelize. SC dot. There's no difference between both. Same as put and copy from local. Kind of same command to copy your data from local to HDFS. I'll use parallelize, let's say. Now, after writing parallelize, I don't know what to pass here. Everything is new to me. Again, I will use 2 times tab. You can use 1 time tab. Sometimes if it doesn't come, you can use 2 times. So you can see this is describing me what is the use of parallelize function. It says me you can pass what value you want to create, and you can even pass the number of slices. This thing I will take in a while. What is this number of slices? How can we use the number of slices? So this is the function of parallelize. Now second, I want to see make RDD. Always whenever you want to see anything, you go here and check this. Make RDD says you can pass T and sequence string as an same thing, right? You can pass this sequence T, so you can see the signature of this sequence T, and number of slices will be also required here. So make RDD, and then in this bracket, I will write whatever I want to write. Now there is one Spark documentation also. This is what I personally prefer if I want to grab any information. So you can click on Spark documentation. You can go to any version. Let's say we'll go to 3.0, and there's API docs. Click on API docs and click on Scala. This is all your APIs. This is all your different APIs. Some are mutable, some are immutable, some are using with the Spark SQL, some you're using with the Spark streaming. This is what you should prefer. Whatever you want to search. Let's say you want to search RDD. You type RDD here. You'll get then option for RDD. This is RDD. You can see my cursor, org, and this is coming from a package called org.apache.spark.rdd. So this package is created by Spark community engineer, as in from Apache Software Foundation, and they have given all this function for us. We'll click on this RDD. To get more information about RDD, I click on this, and then right side you can see RDD page is open. And this open, if you want to deep dive into this, you can open the source code also. Okay, so this is like for if you're into research and analysis, you can open this and start checking what exactly they're doing. But I'll not recommend currently. This may confuse you. Option is given. Don't go with this, because this is a job for people who are into research and analytics. So now we'll see two functions which we can pass make RDD and Paralyze. Do we have that option here? Make RDD and paralyze. I'm searching. Oh, sorry. Make RDD and paralyze is a part of SC. I'm searching in a different location. So it's a SC Spark context. Or we can write a Spark context directly. Yes, this is Spark context. Click here and look for that option. So dot, you're seeing dot and tab. This is what is coming when you type dot and tab. You can see make RDD, one function is this, second is this, which says number of default parallelism. Then there's another function called parallelize. This is how you can check it. You can see the description also, why this is created. So this is a best page for you. Before writing multiple job, whatever you're doing, at least don't try to complete more and more example. First complete one example, come here and read what this function is designed for, what it is talking about, what it is saying. It says distribute a local Scala collection to form an RDD. Okay, now we'll go back to here. We are using make RDD and we'll call our, can I say this is 1 to 100? Can I say this is 1 to 100? 1 to 100, and I'll keep this in a bracket, and I can say this is 2 array. I can say this is 2 array because 2 array is a function, and I'll see will it create me any RDD. This is what RDD created. This is a transformation. Now this is what I'm talking about. The question will come, which one is a transformation and which one is an action for you. Start writing here. Make RDD function is a transformation. And simple example, why it's a transformation? Because when I submit, I did not get any output. When I submit, I did not get anything here. I just get one return as org Apache Spark RDD. This is a package. It gave me one RDD. This is all integer. That's why this is integer. And that's it. Now, if I want to see the output of it, right, what should I do? This is a lazy operation, right? Because I'm not giving load to my computation engine. I'm not giving load to my CPU. I'm saying when I want to ask you for action, that time you take it. Now let's say I said I want to handle or I want to access my 0th index dot collect. One second. So if I say r dot collect, what will happen? R dot collect. So when you type r dot collect, you can see you are getting output now. When you're getting output, so what is this? Is this a transformation or is this an action? Whenever you get output, it's action, and when you do not get output, it's transformation. So you'll have to remember this APIs and write this thing here. Now you can type collect is an action, make RDD is transformation, collect is action. Parallelize is also a transformation. Parallelize is also a transformation. Okay, so today we have seen this two things: make RDD, parallelize, and collect. Now what was our requirement? Let's complete it first. Let's see how much time is left. So I think we stop it here. We'll continue from here. Collect and other thing tomorrow.